In this lesson, we're going to learn about translations and vectors. So translations, not to be confused with transformations. So translation is a specific type of transformation. So transformations are the big picture. A translation is a specific type of transformation that slides an object. So what I look at is that SL, standing for sliding. So it's when you slide an object around on a graph or in plane space. So a translation is a rigid motion, which means that if you translate an object, it'll stay the same shape and size. So it's not going to change anything about the object. And you're going to always translate in a certain direction and a certain distance. So the distance will be fixed, which means it'll stay the same, and the direction will be specified as well. A translation is also called a direct isometry, which means, again, isometry, it'll stay congruent, same shape, same size when you do a translation. Direct means that the orientation will stay the same. And then under translation, all points will move the same distance away because the distance is fixed among all of the points. So if you translate a triangle, that distance between the original and the new one will always be the same. Between the pre-image and image points. So we look at this example here. We're going to find the image of this point under these different translations. So the first thing are different notations that we use. So regardless of the notation, this first one is called your function notation. So capital T stands for the translation, and A and B are telling you how to move. And then this next one's called mapping notation. So this is basically, here's your original. You're going to map it onto this new coordinate. So the new coordinate is going to be taking the original and then adding A and B to the X and Y values. And then this last one is called vector notation, which we'll talk about in a little bit what that means. So first of all, I would off to the side here, let's just add, when you see A and B and all of these, what that means is you're going to move A units right or left. That's going to be your horizontal movement. Or you could think of it as add A to the X value. That's basically what this one's saying, this mapping notation. And then for B, that's going to be your vertical movement because that corresponds to the Y value. So you're going to move B units up or down. So then if it's positive for the A value, that means right. If it's negative, it means left. You always go towards the positive or negative numbers. And then for B, if it's positive, it's up. If it's negative, you're going down. And then the other way to think of that is just to add B to whatever the Y value is. So basically what I'm writing here are graphical approaches and algebraic approaches. So when I'm talking about moving on a graph or sliding the object around, that's the graphical way. The algebraic way means you're just going to add those values. So if it's a negative, you're technically subtracting, but you're just adding a negative. So if we look at this first example, this right here, those numbers, this indicates that you're really going to be going right 2 on a graph because the 2 corresponds to the horizontal movement, and down 3 because the Y, the negative 3 corresponds to the Y, which is the vertical movement, which means you're going down 3. Or this also means add 2 to the X value, subtract 3 from the Y. So if I start with this point, so here's my starting point. I'm just going to copy it down. So this is 3, negative 1. I'm going to do these operations to them. So it's going to be plus 2 to the X and minus 3 from the Y. And that's how I'm going to get my answer. So it'll be 5, comma, negative 4. So that's going to be my image given the pre-image. So there's the answer. So, and again, you could graph that and then you could just count right 2, down 3 and get the same answer. The next one here you have the function notation, so with a capital T. So this is negative 1 and 0. So negative 1 comma 0 means the negative 1 goes with a horizontal movement. So that would be left 1. and then this would be up or down 0. So you wouldn't be moving up or down. So for this, you would just say left 1, and that's it if you were describing the motion on a graph. If I'm doing this algebraically, it means I'm taking my coordinate. So let me just start with that same coordinate. And we would just be subtracting 1, and then this is really just like plus 0. Using my x and y values, or my a and b, which correspond to x and y. And when you do that, you get 2, -1. And that would be your image, given the pre-image is 3, -1. So that's really it. So you can do these algebraically. You can also do them on the graph. The main thing is just knowing your rules, knowing that the A always corresponds to X, so that's the horizontal, and the B always corresponds to Y, so that's the vertical. And then the only other thing is this vector notation. So first thing you have to know is, what does a vector mean? So a vector is a quantity that has length and direction. So if you remember what I said about a translation, you're always going to be going a fixed distance, so a specified length, and in a given direction. So when I say left 1, up or down 0, I'm telling you which direction to go, and I'm telling you how many to go in that direction. So that's what a vector is doing. So a vector has what's called an initial point, which is where you start, and then a terminal point, which is where you end. So that's how you would be able to find the direction and the length. So you would look from the starting point to the end point. There would be an arrow indicating which direction you're going, and then the length is going to be how far you go. So on a graph, we can't count diagonally. So what we use is the horizontal and vertical component. So when we talk about a vector, we're talking about it in component form, which looks like this, and it has those sideways V-shaped brackets. You can remember that for vector. And A is the horizontal component. Which basically tells you your right or left movement. So this would be right or left A units. Or add that value to the x. And then B is the vertical component. So that's going to tell you up or down B units. Or adding that B value to your y coordinate. So basically this notation is called the vector notation, but it's really the same thing as what you saw with the other translation rules. So if we look at this, it says what vector describes this translation. So when we're identifying vectors, or anytime you're looking at transformations, you always want to start with the non-primes and how did I get to the prime. So this is my starting figure, and then the image is the has the prime values. So the vector, if we were to sketch this in, would be from A to A prime. See how that direction and distance is the same as if I were to connect B to B prime, and if I were to connect C to C prime. So those are all vectors because they tell us the direction and the distance to travel. So now I've drawn the vectors in, but I actually want to state the vector using component form. So the vector, so we'll basically just count one of them, and they're all going to be the same. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. So it was down 9. And then over 1, 2, 3, 4. So that means this is the component form. So we went right 4, so it's going to be a positive 4. And we went down 9, so that's going to be a negative 9. So this is the component form to describe the vectors that I've drawn in purple. And you can check it. If I go from C to C prime, it should be the same. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then over 1, 2, 3, 4. And remember, I switched the order of these because it's always the horizontal movement, then the vertical movement. Okay, so that's it. Go ahead and try the check your understanding problems.